barrel roll.
The past 3 clips were showcases of the possible directional movement of an aircraft. These movements are called rolling, pitching, as well as yawing. Now one might wonder how exactly these movements are performed. This is done through the directional components of an aircraft. Take this aircraft for example. It consists of an elevator, a rudder, and ailerons, which are each responsible for pitching, yawing, and rolling respectively. However, if you were to look at the Boeing 737 for example, the components are clearly visible. Although, how do they respond to the input of a pilot? That is quite difficult to see from the outside. To demonstrate the general, globally used system of movement, I have created this small model. This green bit represents the servo, or the input such as a switch on a pilot's seat. The servo is connected to a control horn, which is connected to a push-pull rod, who in response moves the rod bound to another control horn, which is connected to the component itself. For a recent project, me and my group worked on a miniature firefighting drone. This is the kinematic design of that drone for the directional components. Its components are one-to-one with the aforementioned model. The deflection of the rudder is 30 degrees both ways, for the elevator is 20 degrees both ways, and for the aileron is 25 degrees up and 15 degrees down respectively. As a drone, it must be remote controlled, hence through a controller and a bit of coding, the servos are controlled through a board that ties everything together. This is what the kinematic design looks like when it's fully incorporated into one of the components, specifically the rudder. And finally, with the readings of the sensors on the plane, adjustments can be made with the controller to control the drone in flight,